Much of our modern atomic theory was derived from John Dalton's atomic theory that he developed in the early 1800s. So he developed this theory to explain the main scientific laws that we've talked about in a previous lesson: the law of conservation of mass, law of definite proportions, and law of multiple proportions. So if you need a little bit of a review on these, make sure you go back to the previous video to get a full description of what each of these laws is. So Dalton came up with this theory to try to explain why these laws were the way they are. So remember, a scientific law describes and summarizes scientific observations. A scientific theory aims to describe why those laws and hypotheses and observations are the way they are. So here was John Dalton's explanation for why matter was observed to do what it does. His first point was that each atom is made up of tiny, indestructible particles called atoms, and these atoms are the smallest unit that an element could be while still retaining its identity, its recognizable identity as that element. The second point was that all atoms of a given element have the same mass and properties as other atoms of the same element. What this means is that a hydrogen atom would have the same mass and the same properties as any other hydrogen atom. A carbon atom would have the same mass and properties as any other carbon atom, and so on. We're going to come back to this in a moment because, as we'll see, this isn't the whole story. His third point was that atoms combine in simple whole number ratios to form compounds. So we saw this already with the law of multiple proportions, that you're never going to have a fraction of an atom combining to form a compound. And the fourth point is that atoms of one element cannot change into atoms of another element. They can only change the way they're bound together. So, for example, you can't have a hydrogen changing into an oxygen, but you can have a hydrogen atom changing the way it's bound to an oxygen. But again, this is another one we're going to come back to in just a moment, because some points that Dalton made were later proven false. So remember that scientific experimentation can never prove a hypothesis to be true. We can only prove hypotheses to be false, or we can only disprove hypotheses. So some of these were disproven, or at least shown to not be the entire truth. So the first one I want to focus on is the second one, that all atoms of a given element have the same mass and properties as all other atoms of the same element. We're actually going to talk about this later today, about how certain atoms, even though they are the same type of atom, might have a slightly different mass and properties because they are what are known as isotopes. And those are atoms that have a slightly different mass because they have different numbers of neutrons. Numbers 1 and 4 were also proven to be not the entire truth when later in the 1800s, Marie Curie and others were doing a lot of work into radioactivity and found that atoms can, in fact, change into atoms of another element through radioactive decay.